Okay, the first skill that you should have is to be able to convert moles to particles. When I say particles, I mean atoms or molecules. It could be either one. So instead of I say atom and molecule, I just say one word, particle, same thing, okay? Or particles back to mole, convert back and forth, all right? So let's say you have mole, 2, 3 moles, 5 moles, whatever. How do you convert that to atoms or particle? Well, what's the relationship between moles and particle? Well, the word mole itself is equal to 6.02 times 10 to the 23rd, whatever you're talking about, right? 1 mole of orange is 6.02 times 10 to the 23rd oranges, basically, right? So 1 mole of a particle or atom or molecule is 6.02 times 10 to the 23rd particles. So you're going to time moles with this conversion factor, like that. Now, if you have particles, so we can go backward, same thing. We just flip this. So particle is going to be at the bottom and mole is going to be at the top, right? So particle we cancel out, and 1 mole is 6.02 times 10 to the 23rd particles, or we call Avogadro's number. Okay. All right. I'll do the first one for you. You do the other one. Okay. So if 1 milliliter of seawater contains that moles of dissolved gold, so we have moles of gold. How many atoms of gold are in that volume of seawater? All right. So we have moles. We have to go to atoms. Right. So we're gonna times the term that have moles at the bottom, so it cancel out, and then put particle at the top. All right. So we want to know the atom of gold. Okay, what we have 2.50 times 10 to the negative 14 moles of gold. All right, convert mole to atom. What's the relationship between mole to atom? So put mole at the bottom, atom at the top. 1 mole is 6.02 times 10 to the 23rd atom. Okay, mole of gold cancel out. Do the math right here. You get that. Okay, they are 3 sig figs, so watch out. So we have to round them up. You get 1.51 times 10 to the 10th atom gold. All right, pause the video. Now your turn. So this one you have to convert molecules back to moles. All right, convert molecules back to moles. So how many moles of water are in the plastic bottle containing 1.204 times 10 to the 23rd water molecules? All right, so we want moles of water. So I put it right here. What do we have? We have 1.204 times 10 to the 23rd molecules. Okay. Now, what's the relationship between moles and molecules? Well, 1 mole is 6.02 times 10 to the 23rd molecules. All right. I'm going to put molecules at the bottom, moles at the top. So molecules can cancel out. All right. So 6.02 times 10 to the 23rd molecules. That is 1 mole. Molecule of water cancel each other out, and the rest you do the math there. So you get 0.2000 mole water. 4 sig figs. That's why I put 4 sig figs here. Okay. Now some of you may ask, hey, hold on. We get the sig figs, but hey, 4 sig figs, 3 sig figs. Shouldn't the answer be 3 sig figs though? Well, normally it's true, yes, but don't remember. This is an exact number. Do you remember what the exact number is about? Right? So this number does not have an uncertainty. Okay, and like 12 eggs in a carton. 1 mile is 1.609 kilometer. Those are the conversion factor or the definition. Those do not have uncertainty. When you count number of significant figures, we just ignore those. Okay. All right, back right here. So I just want to confirm that you guys actually know what 1 Avogadro's mean. What the Avogadro's number mean, right? Avogadro's number is really, really massive quantity, really massive. For example here, 6.02 times 10 to the 23rd oranges. Well, this number of oranges can fill up the entire surface of Earth. Not only that, it built up, it just get on top of each other up to the sky, about 9 miles up to the sky. That's a big number of oranges, right? So the Avogadro's number is really, really big number. The money, let's say you have a 6.02 times 10 to the 23rd dollars. How much is that? It's a big number. Let's say you spend like trash, like spend like excessively $1 million per year. I don't even think you guys spend $1 million per year. No, unless you buy a house, yeah. But normally we not just eat to live. You're not gonna spend $1 million per year. But let's say you do. Okay, how many years it would take you to use up the 6.02 times 10 to the 23rd dollars? Okay, let's convert unit real quick. So how many years? You want to know how many years? How much do we have? We have 6.02 times 10 to the 23rd dollars. All right. So I'm going to put and every year we spend $1 million. So I'm going to put $1 million at the bottom, and that's per year. All right. So we spend $1 million per year. Okay. So dollar cancel out. You do the math there. You should get 6.02 times 10 to the 17 year. That's 10 to the 17. 10 to the 6 is a million year, right? 10 to the 6, 10 to the 12, million. 10 to the 18, that million. This is almost a million year. We don't even live that long. We only just 100 years. So that's why we because atoms and molecules are really super teeny tiny, very small particle. That's why we need a unit. We need a quantity that can represent this small particle. This unit is really big. All right, and Avogadros do just like that. Okay, so we need a big unit. And the weight of 1 mole of substance, I'll take a look right here. So the weight of 1 mole of substance are different. 1 mole of carbon atom, 1 mole of water molecules, 1 mole of iron atoms, and 1 mole of helium atoms. They all have different weights. Right? Take this, a mole of carbon, put on the weight on the scale is 12.01 gram, which is exactly like an atomic number in atomic mass unit. It's, I don't know, is it coincident or not? Right, but there's some relationship, but we don't talk about it, right? But it looks like there's it's a coincidence, right? The gram is equal to the grams of 1 mole is equal to the atomic mass in atomic mass unit, right? Water, the 1 mole of water weight 18.02 grams, which is exactly the mass atomic mass of 1 oxygen plus 2 hydrogen combined. Okay, the weight of a mole of iron is 55.85 grams, also equal to the atomic weight in atomic mass unit of iron. And same thing with helium. So put 1 mole of helium, put on the scale 4 grams, 4 AMU per each helium. So to make it in the picture a little bit better, so 12 grams of carbon is about that. All right, 55.85 grams of iron. Now, iron nails looks like that. Okay, so that's 1 mole. 1 mole of copper is about that. 1 mole of sulfur, that's powder, and 1 mole of the only liquid metal in the periodic table is mercury. It's about that, and that is 1 mole. That's a punchline. Bam, push off. All right, chapter 7. So class activity number 1. I gave you the key, the answer. So all you have to do is just show your work, convert unit conversion. Okay. All right, let's check. Look at the next video.